Alright, let's solve the Leetcode problem. I think these days everything related to stock price. So the Leetcode problem is the best time to buy and sell stock using the strategy. So we are given a two integer array, price and strategy in here. Where the price of index is the price given stock on the I day, and strategy represent a trading option on the I day where the -1 indicate buying 1 unit. So let's try to write it down. 1 mean buy 1 unit. 0 mean like holding the stock, and then 1 indicate selling 1 unit. So that is just an indicator of what to do for the strategy. So we are also given an even integer, so we may perform at most 1 modifications to the strategy. Okay, at most. Okay, a modification consists of the selecting the exactly consecutive elements. That means that we can do the something like 0, 1 or 1, 2 exactly strategy, and then need to set the first key by 2 element whole, set the lets key by 2 to sell. Okay, that makes sense. And then the profit is defined as the sum of the strategy multiplied by price across all day. We have to retain the maximum possible profits that we can achieve. So there is no constraint on budget or stock ownership, so we can buy and sell operation as feasible regardless of the past action. So if we go through the example given in here, so we're given like a 3 price, let's call it Monday, Tuesday, and Wednesday, 4 to 8. So for the Monday, what are we going to do is, I will copy that and then paste in here. So for the first day, we got a -1. So we are buying the 1 unit. So buying the 1 unit of the 4 mean like -1 multiplied by 4. And then next is 0. That means like holding the stock. So we don't do nothing, just 0 multiplied by 2. And then that strategy is selling 1 unit. So 8 into 1 is 8. So total combination will be the 4 minus 4, 0, and 8 will be 4. Well, that makes sense. What about we modifying the 0 and 1? Since we are given the 2 even k artifact in here, so according to the artifact arbitrary values, what we can do is we can choose like 0, 1, 1, 2. These two are 2 consecutive numbers of the events. We're gonna choose like 0, 2, or like 1, 3. But in our case, since the array is given like only 3 items, that is 0, 1, 2 for index. So what we could do is a 2 maximum operation, 0, 1 or 1, 2. So we're going to change the 0, 1 into the, instead of buying, we are doing nothing for the first operation. For the second operation, instead of holding, we are buying 1 unit. And then the third one remain as if for now. So 0 multiplied by 4 is 0, and then 1 multiplied by 2 is 2, and then 8. So 8 plus 2 is 10. So the same for the last one. So we're trying to manipulate. At the end, the maximum value is became the 10, and the output here became the 10. I think that is the same here also. So we're given the 2 as arbitrary values. So we can do 0, 1 or 1, 2. So we can swap like 1 into the 0. So there's a lot of possibility. Since we see the 1 as original, we can do 2 things. We can change the strategy to hold or buy, since it's showing the 1 as a selling unit. And then next step is for the 1, we can keep it as if for now, or we can change it to the hold or buy, since it's showing the 1, but we decided to keep it like 1 thing. So after doing the same operation, what we got is the maximum is a 9. I think that is a dynamic programming each sliding window, because it's keep comparing the numbers again and again. Same approach. Let me use a count for the price.count. The reason why I can use a strategy and price will be always the same range. So let's consider like profit sum. I was trying to use the dynamic programming approach to solve this problem. Beating of 0 and then count will be the count plus 1. Next will be the price sum. So I can just copy paste and just rename the variable name here. So next step is I'm gonna assemble the data for profit sum and price sum. So what I would like to do is, instead of going through one by one, I would use it like, let's call it the price will be the price of index, and next will be strategy. That will be the very weird name. Let's go S. And then what I want to do is profit sum is index plus 1, since we don't want to use the origin 0 to resolve for our answer. And then I'm gonna update the profit sum. Since the profits in here mention that we have to multiply the strategy and the profits. So okay, I'm gonna keep the original values, which is 0. So whatever we do plus or minus to 0, that doesn't matter. And then I'm gonna multiply with the price and strategy. So for the price sum, it's just to accumulate the price. What I want to do is price sum of index plus price. So what I'm doing here is I am just multiplying the strategy with the price to measure what is the possibility that we could find in here. Let's consider that we saw the approach like okay, let's consider the price sum. So we are manipulating the data in here. So if we print it out, the price will be the 4, 6 and 14. Okay, I just trying to accumulate it. Maybe I will, okay, let's call like reset will be the profit sum of our count, because we want to keep our values in using the top down approach. And then let's call like a half. That will be the k by 2. Okay, let me return the result in here. I'm gonna print out the profit sum and price sum. So if we calculate the profit sum, there should be the count. I always make a mistake like writing the count as an n. I don't know why. Maybe that's the old habit. Profit so okay, some case was correct. So if we check in here, so we keep index from 0 to the 2, since we only have a total of 3 items in each array. So what I'm doing here is I am just keeping update of the price values. Okay, here we got the 4. So if we jump to the next step, I accumulate the 4 and 2, that became the 6. And then 6 plus 8 became the 14. So that is the accumulation of the price sum. For the strategy, I am just multiplying the price and sum. Let's say 4 and minus 1 became the minus 4. The next step, I will keep the previous value, and then I'm gonna multiply with the 2 and 0 and plus. So 2 multiplying by 0 is 0, and then our minus will remain the same. So next step is 8 multiplying by 1 is 8. 8 plus minus 4 became the 4. So that is what I'm doing here. So by doing that, I don't need to recall back the previous how to say, the previous number again and again. So that is the valuation of using the top-down approach in the dynamic programming. And what I only need to do is I just need to calculate the sliding window approach to get our final result. Let's calculate like if k is less than or equal to the count, since even though we have a k values origin, we just want to enter to the operation. Then let's call it for index in k minus 1. So the reason why I'm detecting the k is it will always provide the even number. So we are receiving the numbers like somewhere between the 2 to 10 power 5, which is like 10,000. And then, wait, it's 10,000. Yeah, correct, 10,000. And then I want to go through till the end of the count. So by doing that, what I do is I can calculate the start. So to calculate the start, index minus k plus 1. So let's call like our index is, we start from the k is 2. 2 minus 1 is 1 till the count. So that is what we want to do. So 1, 2, 3. So we got the index like 1 in here. Count. Okay, I don't know why I'm doing like this. So index is a 1 in here. 1 minus 2 plus 1. So that is technically 0. So that is how we calculate the start index, and then we will calculate like left profit and right profits. So what I'm doing is, since we have an index of to split the consecutive array into the left and right, so let's call like left profit initially. What I want to do is I will get the profit sum by using the start, because left is technically sure I start from the index 0. And then for the right, that is a little bit different from what we know as a 2-point approach. So let's call the right profits. So to calculate the right profits, we need to calculate after the window. So we have like profit sum and then count. So that is technically end of the array for the dynamic program, since we have a plus 1 in here. So technically we are calculating the profit sum is checking the right side of the value, something like 14s in here. That is what we are checking for the profit sum. And then I'm gonna detect the profits sum from I index plus 1. So technically, let's say that we are receiving this value as a profit sum. Okay, let's call it here. And now what I'm doing here is I am calculating the less valuation, this value, by detecting the profit sum index plus 1. So our index plus 1 is here. So since our index is 0, index is 1 plus 2, sorry, so it's here. So it's 14 minus 6, which will be the 8. So we are trying to revert back the original price of the here. So that is the right profits before we do anything. And then that is the real game changer, what we want to calculate, like change profit. That will be the price sum of, okay, yeah, that will be the price sum of index plus 1. So we are having an index in here. Index plus 1 will be the next item, and then minus price sum of index minus half, where the half is coming from. So we have a valid givens in here. Set the first k minus k divided by 2 elements to 0. So that's what we are doing, using the half and the plus 1 for the sake of our dynamic programming, since we have an extra 1 room for that. And then we can calculate the candidate in our case already. How can we calculate it? Left profits and change profits. So there is a difference, and then we just plug text with the right prefix. So by doing that, what we can check is, we'll check with if candidate is greater than our result. If yes, so our result originally is a proficient of here. So technically, which is original values of 4 initially. So if larger than the 4, we're gonna update the result with the candidate. Now at the end, we just finally return the result. Let me check if I done any typos or any stupid in here. Yep, and that is also straightforward. And then I think space and time complexity will be the O of n for both, since we don't use any extra array as, oh, okay, n square. Wait, it shouldn't be n square because we don't have any nested in here. Why? Let me double check again. Okay, n square. That's the interesting part. Let me check the space complexity. That should be the O of n. Yep. I have no idea how it's become the n square. Wait, let me check. I don't do any nested for loop in here. Or maybe the problem of Leetcode? Not really. Okay, let's try to submit again. It should not be the O of n square. Maybe only possibility is Leetcode do something wrong. I don't know. Alright, that's all for it, and let's see you in the next video. Bye.